aniline is a very strong electron donating groups. It's a pi donor. It's an order pair directors. So you can imagine that due to nitration, you're thinking that, oh yeah, sure, of course, nitro is going to go to parentage. That's most likely. Or maybe you would kind of detect like this, this is something wrong in there. This will never make that, right? Because this is a really strong acidic condition. Amine is going to be protonated. Then once amine becomes protonated, that makes a very strong deactivators. So nitro will go to meta condition, not this. So that is what we know. And that will be what happened. The question is, what I'm asking here is, yeah, that's what happened. But regardless, you want to make this, then what are you going to do? This is a very goal-driven question. I mean, understanding how the nature works is the one thing, but making something happen is another thing. If you do the nitration reaction to the aniline, you will have a nitro group for the meta position, not the para position. That's basically what happens. But in the end, let's say your boss asks you to make this regardless, then what are you going to do? That's why you need some other way to make it out. The reason why amine somehow becomes a meta director is because it gets protonated. That's the reason. So what we could do, we could make the amine not basic. The only thing we need to do, make the amine not basic. That's the only thing that we should do. So how are we going to do it? We're going to make an amide unit. The acid chloride, we're going to name, this is the reactor we just talked about. It will make an amide. When it makes an amide, these nitrogens still have a lone pair, even though that lone pair can make a resonance structure with this, still this is a lone pair. So that makes us an activator. This is a pi activator. Not the most strong activators. If you look at the order of the substituents, the activators, this amide nitrogen is not the strong one, but however, still it's a still parameter. Strong acid will not make an amide protonated. Because this lone pair of the nitrogens, that's what we talked about so long time. This lone pair of nitrogen is not on sp3 orbital. They're not basic, they're sp2. They're relatively p orbital, making resonance structures with this carbonyl here, right? See? That's the reason these nitrogen lone pairs of amide, not basic at all. So even though this strong acidic condition, these won't be protonated. So this is still remaining ortho para directors, even at the strong acidic conditions. So when you convert amine into amide by reacting with the acid chloride, if you do the nitration reaction, nitro group is going to go to ortho or the para position. But this is not what we want. We want this. So we need to clean that away. I mean, this is the things that we're going to discuss much later, but we can hydrolyze by acidic water, strong acid and water, you cook it up, then you can get rid of these things, and then you can have an amine. So this is a strategy that you can use to make para substitution or ortho substitution of the aniline, nitration reaction. So this is kind of the protecting strategy we're talking about. It's sort of like a protecting amine as an amide, and then remove the amide, which means the deprotection steps, and get rid of it. So starting from the alcohol, we got seven protecting groups. If the carbonyl gets in the way, we got the acetylcyclic acetyl protecting groups. When it becomes an amine, now we're going to talk about amide as a protecting group. So see here, we are providing strategies when we're expecting a trouble, with the trouble originating from the amine lone pair, we can probably handle that issue this way. Making as an amide, do the reactions, and then break it away so you get an amine back. So I want you to think about these strategies. So another reactions on the same topic. This is a Friedel-Crafts alkylation reaction. The previous reaction, you can imagine that if we use a strong acid like the nitric acid, sulfuric acid, so amide gets protonated, it becomes a strong amide. That is understandable. What about this one? Doesn't have an acid there. It looks like we have alkyl chloride and then the aluminum chloride there. We don't see nitric acid. We don't see sulfuric acid. We don't expect this nitrogen to be protonated there. So if you go for the reactions, easy, and with all the parent reactors. So by putting it together, you're going to make them called cations, and the cations are supposed to go to the parent positions, right? So that would probably answer you're going to put. And the reality is, this is not going to happen. So why is that? Why is it not happening? Because there's no acid there. Nothing complicated the issue again. If you do see the strong acid, then yes, that's understandable. But here, I don't see any acid yet. Why the reaction doesn't go? The reaction doesn't go is because of this aluminum chloride. I hope you remember what we described it as. We described it as Lewis acid. What is a Lewis acid means? It can accept the lone pair. That's the concept of the Lewis acid. Species that can accept the lone pair. Species that can donate the lone pair is called Lewis base. So aluminum chloride is a Lewis acid, and then this amine is a Lewis base. Again, acid-base reactions. They're going to come together, and then when they become complex like this, no more Friedel-Crafts alkylation reaction. So even though you don't see nitric acid, sulfuric acid, but Lewis acid just being a good acid, and it can also stop the reaction just like that. So that becomes an issue also. So again, if you want to make it happen, then what you can do, use the concept you learned before, which is reacting with an acid chloride, that makes an amide, right? Once it makes an amide, these lone pairs are still there, they're not going to be basic. So they're not going to react with the Lewis acid. You can go through the Friedel-Crafts alkylation without any problems. So you're going to get that these methyl-glycerol conditions. Only thing that you need is breaking that up, which is adding water and strong acid and cook it up. Then, or you can do the basic condition too. That way, you can make this Friedel-Crafts alkylation without that complication. So this is again what we call the protecting strategies. Acetyl groups, acetyl chloride becomes a protecting groups, and then getting rid of that in the breaking of the water, which is called hydrolysis, is a protecting steps.